Welcome back to Designing AI-driven Personalized Learning Environments course. In this video, we'll discuss rule-based model in the domain model. Rule-based model or RBM is one of the major model used in the domain model. It is based on ACTA theory, that is adaptive control of thought rational theory, developed by John Anderson at Carnegie Mellon University. I think we discussed this in the first week about how the evolution of ideas is happening and major contribution from CMU also happened. The ACTA theory, the basic theoretical focus, if I break into it, it is about human cognition, that is a cognitism. And in a human cognitism learning approach, a problem can be solved by breaking into a small chunks of problems and connecting it together. The idea is that take any complex problem, break the complex problem into sub problems, and if you have the the sequence is clearly driven. For subproblem 1 has to be done, then subproblem 2 has to be done. If you have the series is given, you could able to create a you could able to solve the problem. That is the idea. So adaptive control of thoughts. That's the idea of this basic fundamental idea. But if you need more detail, I would request you to go and check the ACTA theory from Professor John Anderson's research papers. So the goal is, if I break down the given problem into a multiple steps, you are not checking the final answer, you are checking the answer at the each step, so that you could able to find out what is the students challenges while solving the step. You could provide feedback at the each step instead of giving feedback at a whole problem. Okay, we will go into detail how this kind of theory helps us in developing rule-based model. And it has set of production rules, if and then structure. Its knowledge is represented as a set of conditional statements. For example, if the condition matches with the goal and state of the problem, then do particular action. Okay. If the goal is to isolate a variable from a constant in algebraic equation, suppose if a goal is to isolate a variable, the variable can be x, the constant can be 3. If the goal is to isolate a constant from this, from this equation, then simple rule is subtract that constant from both sides of equation. So subtract that constant, that is the constant here is 3, subtract the constant at the both side of equation. So this will be minus 3. Okay, that's the idea. So make your problem into a subproblems, and each subproblem make a discrete if else condition, if then conditions. If the condition matches your goal, then do this particular action. That's all. If a student is not doing that action, we could give a feedback saying that you should subtract the constant from both sides. That's all you have to do. So we will go in detail about to an example, but this is the production rules you have to create for the rule-based models. Then we can also have the bug library or the buggy rules or the misconceptions. For each problem, a student might have a misconception at each steps. Based on the expertise, based on the research conducted in a particular topic, you could create a misconceptions or bug library together, then use that to check whether the student is using coding in the particular bug library. Then the student having misconception in a particular step, then you could provide remedial content. For example, if the student is not subtracting this with the minus 3 both sides, student don't know what to do. A student is simply putting x minus x, something like that. Then we know a student is not subtracting constant, instead student is subtracting the variable. That is a bug library. Then you say that the remedial content will be shown that you should subtract the constant, not the variable, because our goal is to identify the value of variable, something like that. So if you know what are the common mistake a student can make that as a buggy rules. If the student state is matched to the target goal, and then if a student is doing a correct action, it's correct, give them the mark. If the student the action is matching to one of the bug library, then give them remedial content. That is the logic. And also we can do the model tracing. The idea is that you could trace the students each action and step based on the the behavior they are doing in the system. Since you are breaking down the whole problem to multiple steps, you could trace the problem, and if user's action is correct with the expert rule, give them a mark, move on to next step. If the student's action is matching with one of the rules in the bug library, that is a misconception rule, give them a specific hint to support the learner to avoid the misconception. If the student action did not match in the correct rule, also not in the bug library rule, maybe a student is making a generic error, the error can be very general, or the student is knowing something, is entering some wrong answer. Okay. For a very simple example, suppose I wanted to add 76 plus 37. Okay. One of the common misconception is the student having in addition this is the carry forward missing. They put 6 and 7, 6 plus 7 is they put 13. Instead of putting 1 over here in carry forward, they put it here. 7 plus 3, 10. So here the mistake, one of the common misconception is that the student is simply adding but not doing the carry forward. They don't know the rules of how to club the ones to the tens. Now, this is one of the common misconception. If I catch this particular mistake, the system can say how to do the carry forward, how to club 6 plus 7 is 13, 13 means 1 10 and 3 ones, how to add the tens to tens position like zeros here, tens position here, something like that. If the same problem, if the same system, a student is knowing the carry forward but did not adding it, he put the value but did not adding it, it did only 10. Here the student knows the carry forward but he did the additional mistake, or he did not know how to add it in the tens position. So I can give feedback. In the same problem, if a student gives a mistake in the sense 6 plus 7 instead of 13 you put a 12 and this put 11, then there is a mistake in the student's addition. The student don't know how to add, or he slipped the particular thing. In the problem, if a student gives some random number, this doesn't qualify the rule because 76 is really less than 76. So there's a general error. Our student don't know any addition. Student did not understand the question, something like that. Our student is randomly entering the values if you know the time span spent on the particular answer. Now you might have one particular correct rule. You might have a 2, 3 buggy rule. One non-rules matching also possible. This is how you have to trace the learner's actions in the RBM model tracing. There's one more thing called student tracing, where you could use this knowledge to understand the student's skill by using Bayesian knowledge tracing method. This we'll discuss in the learner modeling in the next week. So thank you. Next video we'll talk about RBM with more example.